So in this video, we'll be seeing about Gauss law. Gauss law states that the total electric flux present inside a surface is equal to the charge present in that surface. That is, integral closed integral of d dot ds is equals to q. Now let's see a proof regarding that. So for proving the above equation, given equation, we'll consider the spherical coordinate system where integral of dr dot dsr is equals to q. And we know that dr is equals to q by 4 pi r square into ar cap, and dsr is equals to r square sine theta d theta d phi ar cap. So now consider taking the LHS where integral of dr dot dsr is equals to substituting the values of dr and dsr, we get it as integral of q by 4 pi r square ar cap dot r square sine theta d phi ar cap. Because both the directions are same, that is ar cap and ar cap, it's going to be 1, and then r square and r square will get cancelled. So we remain with integral of q by 4 pi sine theta d phi. Applying the limits for theta and phi, we get it as integral of 0 to pi and integral of 0 to 2 pi q by 4 pi sine theta d phi. On solving this, we get it as integration of sine theta equals to minus cos theta, and integration of 1 d phi should be phi, and limits are 0 to pi and 0 to 2 pi. Now solving this, we get it as q by 4 pi into 2 pi after applying the limits. So now 4 and 2 and 2 will get cancelled, and then pi and pi gets cancelled. So it's equal to q. Hence, LHS is equal to RHS because the above equation of Gauss law states that integral closed integral of T dot ds is equals to Q, and we found out the value of the LHS to be Q. So LHS is equal to RHS, and the proof is done. So now let's see a few applications of Gauss law. So Gauss law is applied in calculating the field of symmetric charge distribution. It's applied in determining electric field inside and outside the conductor, finding electric flux, capacitors, charge distribution and conductors, charged insulators, electrostatics, shielding, dielectrics, etc. So let's see about them one by one. Calculating electric field of symmetric charge distribution, where we have spherical system, spherical symmetry, cylindrical symmetry, and then planar symmetry. So for a point charge on a spherical symmetric charge distribution, Gauss law helps derive the electric field. For example, the electric field outside an uniform charge sphere is similar to that of a point charge. And then for cylindrical symmetry, for an infinitely long line of charge, Gauss law is used to find the electric field by considering a cylindrical Gaussian surface. And for plane symmetry, for an infinite sheet of charge, Gauss law can be used to determine the electric field by considering a pillbox shaped Gaussian surface. So now let's see about determining electric field intensity and outside conductors. So inside conductors, Gauss law indicates that the electric field intensity inside the conductor is zero in electrostatic equilibrium because the charges reside on the surface. Outside conductors, the electric field just outside and conductor is perpendicular to the surface and can be calculated using the surface charge density. Now finding electric flux. Gauss law is instrumental in calculating the electric flux through a given surface, which is particularly useful in complex geometrics where direct integration might be difficult. So now seeing about the applications of Gauss law and capacitors. Gauss law is used to derive the electric field and potential difference between the plates of capacitors such as parallel plate capacitor, cylindrical capacitor, and spherical capacitor. Now application of Gauss law and electrostatic shielding. By using Gauss laws, one can explain the concept of electrostatic shielding where the electric field inside a hollow conductor is zero regardless of charge outside. And the application of it in dielectrics is Gauss law can be adapted to include dielectric materials, helping to determine the electric field in and around the dielectric material by considering the bound charges. Now, for charge insulators, for non-conducting materials with a volume charge density, Gauss law is used to find the electric field both inside and outside the material. Charge distribution on conductors, it helps explain the distribution of charges on conductors, particularly the fact that excess charge resides on the surface of a conductor. So that's it for this video. Thank you.